We've got Tom studying science at college. He's learning about ice. Tom does an experiment. He shows that the ratio of an ice cube's surface area to its volume affects the time it takes for the ice cube to melt. That makes sense. The bigger the volume, it's going to take longer to melt. This scatter diagram shows his results. So it's the time for the ice cube to melt. On the x-axis, we've got the surface area to volume. So it's the ratio that's along the bottom. And then the time in minutes is going up the y-axis. And it actually looks like there's a sort of a curved, if I was to draw a line of best fit, it looks as if it would be a curved line. Tom has another ice cube. Each side is 2.5 centimeters long. Estimate how long this ice cube will take to melt. 4 marks, that means I've got 8 minutes. What's the important information? The important information, I would say, is this other cube that he's got. We need to estimate how long this ice cube is going to take to melt. And so we've got here surface area to volume is what needs to go along there. And that's what we need to find out because we don't have that. And then we'll find out the time. So I'm just going to underline this surface area to volume. So I need to find the ratio of the surface area to volume. So first of all, I'm going to need to calculate the surface area, and then I'm going to need to calculate the volume so I can work out the ratio. My surface area, so if each side is 2.5 centimeters long, and I know the area of a square is it's going to be 2.5 squared. So I know that the surface area of one side is going to be 2.5 times 2 times 2.5. That's going to give me the area of one of the faces of the cube. And I can use my calculator. So I will, because it's a decimal. 2.5 times 2.5 into my calculator gives me 6.25. So 6.25 centimeters squared is the area of one of the faces. There are 6 faces on a cube. So I need to do 6.25 times 6. And that will give me, going back to my calculator, 37.5. So 37.5 is the surface area, okay? And if you note, I am putting down my working in the working box. This means if I make a mistake at any point, at least when it comes to my assessment being marked, I've written down my process of whatever it is that I've put down there that I have got right, I can get marks for. So that's my surface area. Now I need to calculate the volume. Volume is length times width times height. So that's 2.5 times 2.5 times 2.5. And I'm going to go back to my calculator because I can use my calculator for this. And I've got 15.625. Is my volume. Okay, now comes the tricky part because I need to show the ratio from surface area to volume. Now, I want my volume to be 1. So at the moment, what I've got in my ratio is I've got 37.5 to 15.625. And I can't really work with that. I can't use the graph. So I need my volume to be 1. Now, when it comes to a ratio, it's similar to an equation. So if I want to turn the 15.625 into a 1, then the best way to do that is to divide by 15.625 because anything divided by itself becomes 1. Now, if I'm going to divide the 15.625 by 1, then I need to do the same to the 37.5. So if I do on my calculator 37.5 divided by 15.625, I will get 2.4. So the ratio that we're looking at is 2.4 to 1. Okay, so I can see I've got 2.4 to 1. Now I can read the graph. Now, it's quite tricky to read this graph because it does seem to be a curve. So let me just find where 2.4 would be. So if that's 2 to 1, and there's 5 intervals there, each one must be worth 2. So my 2.4 is going to be on this line. It's going to come somewhere about there, I would say. If I was to draw a curved line of best fit. So I'll work out what that is going across. So these one must go, the time in minutes must go up in units. So 10, 11, 12, 13. So I would say 13 minutes. And what you'll notice if you look at the mark scheme for this particular question is that the answers can come within a range because this graph is quite hard to read and it does say estimate how long this ice cube will take to melt. Then it does mean that answers within a range will be accepted. So we can see ultimately what's being assessed is, as well as being able to calculate ratio, being able to calculate surface area and volume, which is why this question is worth four marks, because I'm using other parts of knowledge, other topics, as well as my ability to read this scatter diagram. But a scatter diagram, by its very nature, is not complete. We're making an estimate here using the data that we have to calculate the time it's going to take